welcome to 4-Dimension Infotech. In the Core Java series, now we are learning about the OOPS concept. So OOPS stands for the Object Oriented Programming Language. Okay, it is a paradigm based on the object. OOPS having the concepts like class, object, encapsulation, inheritance, polymorphisms and abstraction. Okay. So let's see classes and objects in Java. So here class is blueprint for creating an object and object is the instance of a class. We can define as class is a collection of similar types of object, or it is a blueprint for an object, or it is a template from which the objects are created. And object can be defined as object is a variable types of a class. It is a real entity. Objects having keyword as a new. So let's see here the example given. Okay, so see class car. Okay, class is a car. Imagine you are designing a blueprint of a car. The blueprint defines how the car should look and what it should do, but not an actual car. You use to blueprint to create a real car. Got it? So here class is the blueprint and object is a real car made from the blueprint. Here object. Okay. So in Java a class defines properties and behavior and object is a real instance of that class. So see here the example is class car. In bracket here we are given the data type is string, color is a variable and the value is red. Void drive is the method and here we write system.out.println. In bracket we have written here driving. After that we have given here semicolon for the terminate this statement. So line by line I will explain. Okay. So class car, this creates a blueprint named car. Okay. String color equals to red. This sets the properties or we can say attributes of the car. Void drive method. Okay. This defines a behavior that is method of the car. And system.out.println driving. Okay. This is the action performed when the drive method is called. Okay. When drive method is called, at that time we will get the output is driving. So creating an object, here we create an object. So object can be write as car, my car equals to new car method, and here we write our method is my car dot drive method. Okay, we are calling the drive method. So new car means make a real car using the blueprint, and my car dot drive method. Okay, my car dot drive method here, this is the statement that tells the car to start driving. So here car, my car equals to new car method, that is object created here, and here we are calling this method. Okay, here we are calling the method. So after writing this whole program, we will get the output is driving because we are calling the method drive method. So we will get output driving. Let's see in the diagram, class having multiple objects. Okay, class can have multiple objects. For example, here class is car class. Okay, and having the objects like Maruti, Audi, BMW. Okay, these are the car names. These are the objects. The main class name is car. Let's see program practically. So we will create here the first of all the package 4D Infotech. Then we create our class name as a car. Then here we write the string color equal to red. This is the non-primitive data type, color is the variable and red is the given value. Then we write here the main method is void drive method.
For this drive method, we write here the system.out.println, and here we write that driving. This is the string which we have to return in the double quote. Then main method, public static void main string args. In that main method, we create our object for the car class. So here the object is car, my car equal to new car methods. Okay. Then we have to write myCar.drive method. When we calling the drive methods, it will goes towards these drive methods, and we will get the output as a driving. So let's see. First of all, save the program and then run as the Java application. We will get the output as driving.
Next point is constructor in Java. It is a special method called when the object is created and same name as the class name. Okay, and there will be in the constructor there will be the no return type. So what is constructor? A constructor is a special type of method that is automatically called and when an object is created. Okay, its name is always the same as the class name. It has no return type. There are two types of constructor, default constructor and parameterized constructor. So let's see. Why do we use the constructor? It is used to initialize the objects when they are created. For example, when you create a car object, you might want to display a message or set default values. So here the types of constructor, default constructor and parameterized constructor. Default constructor means there is no parameters used when we want to create an object without setting any initial value. And parameterized constructor takes argument to set initial value at the time of the object creation. So let's see here class car. This is the one example, okay, for understanding. Let's see here in the diagram, types of constructor, two types, default constructor and parameterized constructor. Here is the example or the default constructor in Java, and here is the parameterized constructor in Java. Okay, so read it carefully. So in this example, okay, let's see. Here class car, here we are given, here the method is car method, and we will write here system.out.println car created. Okay, so here class is the car. The constructor car method runs automatically when we create an object using car c equal to new car method. Okay, for example, car c equal to new car method. So it will print car created. If we create the object for this class, at that time when we calling the car method, so we will get output is car created. Next here, okay, now default constructor. Okay, now we will see the default constructor, this example explanation. Like I will explain the program. Like when you write a new my class, okay, when you write a new my class method, the constructor my class is called default. It prints the message and creates the object. And here is the example. Next is parameterized constructor. In parameterized constructor, here the class name, there is data member, public, constructor name, same as class name, that is arguments. Okay, then we will write here the data members equal to arguments. This is the syntax. So here we will write one example. Class cube in bracket, here curly bracket open, here we write int side, integer is side, integer is int, integer is the data type, side is the variable, public cube in bracket int x, and here we will write side equal to x. So here cube int x is a parameterized constructor. When new cube is called, when new cube, for example, when new cube 1 is called, x becomes the 1 and set the value of the side. So these are the four main pillars of the OOPS. Is encapsulation, abstraction, inheritance and polymorphisms.
Let's see here the program for the default constructor. First of all, we have create here the package is 4-dimension infotech. Then we create here the class name as a car. So here we write public class car. Then here we write the string color. This is the instance variable. Then this code for the default constructor, that is public car. Here color equal to red. This is the default set color. Okay, we have setting here the default color. Then after that we write here the system.out.println, and in the bracket we write here as a string car object created. So here the color is initialized red and a message is print to confirm is car object created. Then we write here the method void drive method. Here we write system.out.println, and in the bracket we have given here the driving as a string. This is the main method public static void main string args. This is the entry point of the program. Car my car equal to new car. This calls the default constructor. It creates a new car object using the default constructor. Here we are creating the object. Then my car dot drive method. Here my car dot drive methods calls the drive method. This drive method. It also prints the car's color. It also prints the car color like my car dot color name. So it will give the output like as, let's see, run as Java application. We will get the output is, first output is car object created, then driving, and after that we get the color is red. Let's see here we will see the program for the parameterized constructor. So this is code for the parameterized constructor. First of all, here we have create the package is Java program. Then here the public class car. So car is the class name. Then here we write here the string color. Okay, so this is the parameterized constructor, that is public car. In bracket we have given here the string car color. Car equal to car color. Okay, so color equal to car color, and here we write system.out.println car object created with the color. Okay, so this is the parameterized constructor. This constructor takes a string parameters called car color. Okay, and it sets the instance variable color to the value passed in. So creating object with a parameter is car my car equal to new car, and here we have given the color name is a blue. So the color of the car becomes blue, means it will pass the color when we creating the object. Okay, so when we run these programs, first of all we have to save the program and run. So run as Java applications, we will get the output as car object created with a color blue. Then next driving, color is blue. So let's see here the first feature of the OOPS, that is inheritance. Inheritance is a process where one class acquires the properties, that is methods and attributes of the another. So why use it the inheritance? Because it is reuse the code and improve the organizations and support the hierarchy. Inheritance, there are the some types. Okay, so single inheritance, multi-level inheritance, multiple inheritance, hybrid inheritance, hierarchical inheritance. These are the types of the inheritance. But in the Java, inheritance, which types of inheritance are supported and which inheritance types are not supported in the Java. So let's see. Single inheritance, multi-level inheritance and hierarchical inheritance are supported in the Java. Okay, and multiple and hybrid, these are not supported in Java using the classes, but with the help of interfaces we can use them. Next here let's see
in inheritance, acquiring the properties from the another class. Here is the example for the single inheritance like class animal. Here we write the method is void it method, and here we write class dot extends animal. Here we write void bark method. Okay, and in multi-level inheritance, see class is animal. Here we write class mammals extends the animal, and after that here we write class dot extends the mammal. For example, here let's see single inheritance class A, class B. Okay, it's extend. Multi-level inheritance like that class A, B, C. Okay, class in inheritance in inheritance of hierarchical inheritance there is class A, class B, class C. Multiple inheritance like this class A, class B, class C, and hybrid inheritance like this. Okay, these are the types of inheritance. We have to remember it that.
Now let's see practically the code for the inheritance. Package declaration package is ABC. So this defines the package named ABC. It helps the organize classes and avoid the name conflicts. Then here we are creating the parent class. Okay, or we can say that a super class. So parent class is animal. Then here we write the void method. So void eat method is there. Here we write system.out.println this animal its food. Okay, then after that we have given the second method is sleep method. For the sleep method we give the statement as this animal sleeps. Here we create the child class. Child class is also called as subclass. So class dog extends animal. Okay, so here the dog class inherit the animal class. Then here we write the void bark method. For the bark method we write the statement the dog barks. It has its own method, bark method. Okay, so subclass having its own method is bark method, which specifies to dog. Then here is the main method, public static void main string args. So for this main method where the program starts running and the dog my dog equal to new dog. Okay, so it creates the object of the dog class. It creates the object for the dog class. Here my dog dot eat method, then my dog dot sleep method, and last is my dog dot bark method. So this method inherit from the animal, and this method my dog dot bark method is own method for the child class. So we will get the output like as, let's see, you have to save this program, then run as Java application. So we will get the output like as animal eats food, this animal sleeps, or last is the bark, the dog barks. So this is the output for this code.
Next is polymorphism. So this is also the OOPS concept. Polymorphisms can be defined as one thing, that is method or operators behaves differently in different situations. Or we can say that polymorphism is a main feature of the OOPS. It can perform in a multiple ways. So in polymorphism there are two types, compile time polymorphisms and runtime polymorphism. Compile time polymorphisms like method overloading and operator overloading, and runtime polymorphisms having the method overriding. See here, in polymorphism, compile time, that is method overloading, it having the same method name but different parameters. Okay, that is compile time. Remember is compile time method is also called as method overloading, and runtime polymorphism is also called as method overriding. So let's see the here compile time can be write the code like void show int a, and here we write the void show is string b. And here we write as class animal. Here we write method is void sound method, and here system.out.println. Here we write as animal sound in double quote because there is a string can be always be written in the double quotes. Next, class dog extends animal class void sound method, and here system.out.println bar. So if we write this program like this, we will get the output, okay, when the sound method is calling. Let's see here in method overloading. Method overloading having same method name but different parameters. But here in the runtime polymorphisms, that is method overriding, it contains this same method, that is sound. Same method, sound, and different behavior. Here is the different behavior, that is method overriding. Let's see here program for the runtime polymorphisms called as the method overriding. Here is the package. This is the parent class, or we can say that the super class is animal. Having the method is void sound method. Okay, so here is the method is the sound methods. It will prints the generic that animal makes a sound. Okay, then here class dog extends animal. Here dog class is the subclass called as the child class. Extend the animal class, that is parent class, or we can say that super class. Okay, it override the sound method with its own version, that is dog barks. Same class cat is the subclass, or we can say child class, extends the animal class, that is parent class. Here also it override the sound method similarly to the dog class, and it overrides the sound method to print the cat news. Here we are creating the main class having the main method, and here a class main class having the animal a here. Okay, so animal a is reference variable of the parent class. Then a equal to new dog method. It assign a dog object to it. Okay, so it can animal reference or dog object. It will assign to the dog object. Next, a dot sound here. It is the output of the dog bars. It will print like that. Okay, even though a is a type of animal, the override method in the dog is executed. Here a equals to new cat, so animal reference cat object. So here a dot sound method call the cat method, cat sound method. Okay, so it will print the cat news. Let's see what is the output for this. So for the first method we have get the dog bars, and second sound method calls the cat news. Here is the code for the polymorphisms, that is for the method overloading called as the compile time polymorphism. Okay, so here we create the package 4-dimension infotech, then the class name as the calculator. Okay, so a class name calculator is created here. It contains the multiple methods named add. Okay, so here is the method add. Method name is add, and but each has the different parameters. See here. So method 1 is add 2 integers. In the method 1 we have to add 2 integers, that is int a and int b. Then second method, here in the second method we are adding the 3 integers, int a, int b, int c. Okay, so these are the 3 integers we are adding here. Next, third method, in the third method we have taken the double. Okay, so we are adding the 2 double values, double a, double b. So we are adding those 2 values. Next, here we have created the main method, and in the main methods we have add the objects for the calculator, that is class is created using. Let's see here. So calculator calc equal to new calculator. This is the object for the calculator.
Now we are calling the methods. Here we are calling the methods like system.out.println add 2 int. Okay, so for the method 1 having the 2 integers, so we are giving the values here. Then for the second method having the 3 integer value, so we are giving the values like 5, 10, 15 here. Then last is for the 2 integers double values, so we are giving here the 2 values in the double form. So we will save this program and run a Java application. Here we will get the output. For the first method we have get the output is 15. Okay, because we are given here the value 5 and 10. So 5 plus 10 we will get the output is 15. Next, for the second method we are passing here the 3 integers. And for that 3 integers we have given here the values is 5, 10, 15. So for this it will add and we will get the output is 30. Okay, 5 plus 10, 15, 15 plus 15, 30. So here is the output is 30. Next, for the third method we are giving the double values, and in that double value we have given the 2.5 and 3.5. These are the two values for the double. So we will get the output is 6.0.
Next is abstraction and encapsulation. Here, abstraction is hiding implementations and showing only the functionality. It can be defined as it's showing only the functionality to the users and hiding the unwanted details from the user. It can be achieved by using the abstract class and interface. So, how using the abstraction with the help of abstract classes and interfaces? And why we use the abstraction? To reduce the complexity and increase the security purpose. Okay, so here abstract class shape, here we write abstract void draw method. And next point is encapsulation. Encapsulation means wrapping data and methods together in a single unit, or we can simply say that wrapping data means variables and code, that is methods, into a single unit, also known as data hiding. It is also known as data hiding. It can be declared variable as a private. It can be declared as a variable private encapsulations, and it uses the getter and setter methods to access them. Okay, it can use the getter and setter method for the accessing purpose. So here is one private int age. Okay, public void set age int a, and here we write age equal to a. Public int get age, that is getter method. Okay, return age. So here let's see the diagram. Abstraction, having the abstract class 0 to 100% abstraction can be accessed, and here in the interface 100% abstraction will be there. Okay,
for the abstraction, so here the code with the abstract class. Here we create the package 4-dimension info. Then here we create the class. Okay, so here the abstract class having the class name is animal. So it cannot contain the instantiated directly. Okay, so can contains both abstract and non-abstract method. Okay, it contains both abstract and non-abstract method. So here the abstract method having the method like abstract void make sound. Okay, abstract void make sound. So this is the method. So in non-abstract method there is the method is void sleep method. Okay, it will print as the statement like animal is sleeping. Next, here the subclasses, that is inherit from the animal class. So class dog extends the animal. Here dog class is the subclass and here animal is the superclass. So it inherits from the animal class. It can override the make sound method and it will get the output like dog barks. Next, second one, the subclass like cat. Cat class extends the animals and it override the make sound method. So it will print like cat meows. In the main class having the main method, so here we write like as animal A. Okay, A equal to new dog. That is upcasting. Okay, so A dot make sound. We will get the output like as dog barks. Okay, and next A dot sleep method. A dot sleep method we are giving the output like as animal is sleeping. Same for the class cat. Okay, so when we calling the A equal to new cat method, for this cat class we are calling the make sound method. At that time we will get the output is cat mews, and for A dot sleep method we will get the output as animal is sleeping. Okay, so we will check this, save program, then run as Java application. We will get here the output as dog barks, animal is sleeping, and second for the cat class we will get cat mews, animal is sleeping. So this is the code for the abstract class. Abstraction having the abstract class.
Now here, these and super, these are the keywords. These and super, these are the keywords. This refers to the current object. So we can write like this dot name equals to name, and super refers to the parent class constructor or method. So we write the super method, that is call parent class constructor, or here we write like super dot display method to call the parent method.